My name is Muhammad Tariq, and in this lecture, we will see the restoration of original message after encoding the message using the Huffman technique. In the last lecture, we discussed in detail how we can compress our textual data and then how we can reduce the size of the data. And we encoded and we compressed sample text, and we got the 54% of reduction in comparison to the original data. So now we have the encoded data, and now we want to restore the original message. So what will happen actually, the sender will send the encoding to the receiver. At receiver end, the data will be restored back into original message. So let's see how we can restore the original message. Here we have the original text, which was the traversing threaded binary trees, and we have this encoded message, which is the original message, but this is the compressed message, and we have some zero combination of zeros and ones. Now, how we can, using this data, how we can get original data? Let's check. So we have this tree that we created in the last lecture, and to restore the message, what actually we need is, so let's say we have this is a sender machine. I'm using S for sender, and this is the receiver machine, and I'm using R for receiver. So the condition here is the receiver should have this tree stored in his system, or this application, the application that the receiver is running, he should have access to this um, tree. Without this tree, this message cannot be restored. So the condition is the sender will somehow send this tree to the receiver, and the receiver will use this tree in order to restore the original message. So now after first condition, let's suppose that the receiver have access to this message, to this tree that we created, the sender has created, and sender has also sent the tree to the receiver. Now let's start decoding and start getting the original message. So now the receiver also have this encoded string. So let's start with the zero. What receiver will do? He will start from the root node, right? From here he will start, and he will pick the first number, which is zero, and he will traverse towards zero. Where zero is located? Is located on the left hand side. So it will traverse to this part. Now the next number is again 0. So he will traverse to left hand side. And the third is 1. He will traverse to the right hand side, which is 1. And then he will get the character T. The receiver will store T somewhere. Let's say it's a list. He can store anywhere. And he will store T, right? And then again, he will go back to the root node, right? He will go back to the root node. And now this first three numbers have been used, right? We will start from the fourth number. Fourth number is 1. So the receiver will traverse towards the right hand side. Then he will have 1 once again. Then he will move towards the 1. Then we have 0, right? Then we have 0. Now we have 0, and now we got the character. So we will keep on traversing until we get some character. So now we have R. We will store R here. Okay. And now after restoring R, what we will do, we will move. So we will mark this that we have traversed or we have used these numbers. Now the sender will receive, or the application will come to the root node, and then he will check the next number, which is 0. So here it's 0. The next is 0 again. Here we have 0 again. And the third number is also 0. So we have 0. Now we got the character, which is A. So now we will write A. And then the same procedure, the application or the receiver will go back to the root node, and we will mark that we have traversed these three numbers also. Now we have 1 1 1. So let's traverse towards 1 1 and 1. Now we haven't reached to any character, so we will keep on traversing. Then we have 0 and 0. Then we have 0 and 0, and now we got a character which is V. We will store the character here, and again we will mark the numbers that we have traversed, this number, and then we will start from the next number. Then we have 1 0 1. Then we have 1, sorry, this is not 1. So we have 1 0 and 1. Now we got the character which is E. So we have E, and then we will remove these, and we will mark that we have traversed these three characters. Then we'll start from the next one, which is 1 1 0 0. Let's start 1 1 and 0. Okay, so after traversing three numbers, we got the character, and we have R. So we have R, and then we will remove this, and we will also mark that we have traversed these numbers. Then we have 0 1 1 1. We have 0 1 1 and 1. So we have S. So we have S, we have stored S, and we will mark that we have traversed these. And now what we will do, we will again come back to the root node, and we will check the next number, which is 101, sorry, 0101. So we have 0101, and we have I. Okay, so we have I here, and now we will use the same procedure. Okay, so we have traversed 0101. So 0101. Okay, so we'll go back to the root node, and the next numbers we have are 011, 011, and then because we haven't yet reached to any any character, so we will again traverse 0110, 011 and 0. So we have N. Okay, and we will mark 0110, and now we have 1001. We have 1001, and again we will have to check one more number, 10010, and this is 0. So we have G. So that's how we have recovered the first number. Okay, we have recovered traversing, and the same way we can completely recover our numbers. So now let's say now we had space. Okay, after the word traversing, we had space. Let's check, do we have the space here? Okay, let's mark 10010 as the traversed. So after marking, now we will have to check for the space. The after this word traversing, we had space. So now let's check, can we recover the space? So we have 1111, 1111, and here we get the space, right? We get the space. Add a space here, and then we will start the next letter from here. So that's how we can recover the numbers. We can recover our original message that the sender has sent. This was the technique to recover the original message, and I would recommend you to write the code on your own. Try yourself first before going to the internet and checking and taking help from internet. I would like to express my gratitude to Dr. Suhail Aslam for the preparation of this lecture. I will see you next time. Thank you.